Topology. Sounds advanced? It's not. I'm going to make it super easy for everyone. So what is an open set? That's the concept for today. An open set, I'm going to give you an example. It's like this blob in the plane which does not include its boundary, hence the dashed lines. Everything inside the blob we're going to consider that is an open set. Why is it an open set? The idea is that no matter what point we pick inside the blob, there's always a wiggle room that if you go in some distance, doesn't matter what direction you go, you're always going to stay within the blob. The fact there is that wiggle room means that this is an open set. So if you get really close to the boundary of the blob, the wiggle room is going to be smaller and smaller, but there's still always some wiggle room. And that's why we say the blob is an open set when you don't include the boundary. What happens when you include the boundary? It's no longer open. Because what happens is if you include the boundary, any part of the boundary, then if you take some point on the boundary, there is going to be no wiggle room in a certain direction. So in this direction, you'd stay in the blob, but you can go in other directions and exit the blob. So that's why it's not open when you include the boundary. Okay, so that's the essence of what an open set is. Let's do a little bit of a pop quiz. First example, the region to the right of a dashed line in the plane. Let's say this is the y-axis. Is this an open set? Well, yes, it is. Same idea. It doesn't matter where you are, there's always going to be a wiggle room no matter what direction you go in. Okay, that's why we say it's open. Example 2, a plus sign. Is this open or not? Well, actually there is no wiggle room around any point. It doesn't matter where you are on the plus sign, most directions you're going to exit the plus sign if you wiggle. So the plus sign is not an open set. What about this region, which is two regions, the inside of a square and the inside of a circle, where you don't include the boundary in each case? It's again an open set. It doesn't matter because in either situation, whether you're inside the square or inside the circle, you're always going to have a wiggle room. No matter how close you are to the boundary, there's always a wiggle room in every direction. It's open. Now, if you want a lot more fun content on topology, introducing compactness, which is very advanced at the Heine-Borel theorem. It's very advanced. I'll teach it to you in 15 minutes and I'll just make it all from scratch. Click down below, you can see that video there. It's a super popular video on my channel. It's going to introduce you to fundamental concepts of topology for people interested in rigorous math. I'll check you out over there and have an amazing day. And please be sure to subscribe for lots more fun math content.